Good day to everybody present. This is Nikun Jain from Berkeley Bell Labs, and I will now be presenting a simulated version of our collaboration client in action for the DARPA Spectrum Collaboration Challenge. So right now, we have our radio and collaboration client along with our simulator loaded up on two SRNs on the Coliseum. In the top left window, you can observe I start the collaboration client on one of the SRNs, and one can start observing the output. I do the symmetric action on another SRN, and one can get those outputs, and one can see that these two are communicating with each other based on some previously existing protocol. We are now starting our simulator in the bottom two windows, which simulates the functioning of a radio. You may observe on the left, the network is being subjected to a load of 30 packets per second, and it is managing to achieve a maximum throughput of 65 packets per second based on a particular random back-off timer generated as per a hunting strategy that you can note in the final column. Symmetrically, the bottom right window has a load of 70 and a back-off timer which is now at max aggressiveness of 100. You can see now the back-off timer in the bottom right window is starting to increase because the load has gone down, and the queues for the other network on the left have started to go up. We can see that the back-off timers on the left, on the other hand, had decreased now to maximum aggressiveness of 100. We are now in an equilibrium stage where both the networks have their back-off timers at 100 and are able to dispense the load equally. At this point, the network on the bottom right corner has a lower load, and you can see it's getting politer with a larger back-off timer, while the network on the left is able to dispense its load. However, now that both the queues are empty, one can see that the guy on the right is becoming politer. Once again, we observe that as the load on the left increases, it gets more aggressive, and the guy on the right gets politer and politer. Now, the queues on the right guy had started to build up, so he managed to get more aggressive. Once again, we can observe we're now in an equilibrium stage of equal load and zero queues on either side. Hence, there is equal aggressiveness on both sides of the network. The back-off timer represents the amount of time on average a network would wait before sending off a packet in a CSMA-style setting. Finally, we see at this equilibrium, they both settle at the maximum aggressiveness, and they share the load equally amongst themselves. Once again, on the right, as the load increases, the guy on the left becomes politer based on messages sent in the collaboration protocol that you can see happening in the top two windows. Thank you. We will now proceed to demonstrate plots of what this looks like if we plot it. So now, as you can observe, I will copy in the files to my local system, where we have the Berkeley Bell Labs analytical pipeline, which will process some of this data in a particular format and generate to us what we require. We will proceed to analyze the data flow over time, along with the aggressiveness as well as the throughput. At this point, we have finished plotting, and let us observe our plots. We can see now, first of all, that we have an offered load over time, which was first increased for one team and decreased for the other, then decreased for that same team and increased for the other, and so on, with equilibrium phases in the middle where they received equal load. We can see that consequently, these plots represent the back-off timer versus time, and at the start, one team was more polite, then the orange team became more polite, then it went back to being aggressive, and the blue team became more polite. Finally, we plot the queue lengths versus time, and one can see that the orange team had higher queue lengths on average in the start, then the blue team, and once again, the orange team. All right, and thank you very much.